Greetings, Saber fans. It's your old pal Megtooth Sith, and it's been a while since I've done a blade building video, and the technology has certainly improved as we've gone on with time. And I think what we're going to do is, I'm going to do another blade building video. So today we're building a 1-inch thin wall blade, and I'm using the Pixel diffuser tube as well as the foam. And the big difference is this time, instead of using the 35-35 pixel strips, I'm going to be using one of these pixel sticks from KR Sabers. So Cal Jerome at KR Sabers, he basically invented this pixel stick PCB, and you have on the pixel PCB, you have your Neopixels mounted on both sides. So no more of the, cutting strips, mending strips, gluing the strips back to back. Basically, it's a very simple, and on the end of the PCB here, you have your 3 pads. You have, if it'll focus, you have positive, negative, and data. Sometimes she don't want to focus, but she's going to. Let me try and hold her steady. You have positive, negative, and data. There you go. Hopefully you can see that now. Positive, negative, and data. So on these, I only run 3 wires. So it's pretty simple. I'm using 22 gauge. Also, it's important to use the Gen 2 foam that you can also get. Now, look, all my supplies for this blade build, and you can see my blade tip and my butt end as well as the target PCB here, which I'm going to show you everything I do on this build. So these KR strips, they're available at, and I'll put links in the video description, but they're available at www.thesaberarmory.com. They're also available and distributed in the United States through the Custom Saber shop. Now you want to be careful not to bend these things because they can break if you bend them too far. This is the 132 pixel, so this is designed for a 34.5-inch blade. They sell them in 2 different sizes. The 34.5-inch size is pretty cool for me because that's pretty much what I build all my blades to. So for this project, you need the KR Pixel Stick, whatever size you want. You need the TCSS Gen 2 foam. This is the Gen 2 foam that was specifically designed for the Pixel Stick, also from KR Sabers. Cal is the man. You're going to need your blade target PCB for connecting the wires to your KR Pixel strip. You're going to need a blade butt end, which this target goes into. Well, then be like that. The blade target actually fits into this, and that's what will receive the pins from our hilt. And lastly, well, not lastly, but next I want to talk about the tip. I use these tips from the Custom Saber shop. Yes, you can get 3D printed tips off Shapeways and other sites cheaper, but these hollow tips from the Custom Saber shop, they really color match the blades well. They almost look seamless as you can get. And they also provide to allow for the KR Pixel strip to get into the blade tip to allow for even illumination of the blade. Lastly, the last of the components needed. This is a 1-inch thin wall blade. Now, along with the thin wall blade, if you can see that little piece moving in the middle, this white here is the Pixel strip diffuser from the Custom Saber shop. And I'm using a clear blade, so I'm using this white strip diffuser inside the clear blade. When I do trans white, I do not use the strip diffuser, but since I'm using a clear blade, I'm going to use the strip diffuser. So that's the last of the components needed to build the blade. Next, I'm going to talk about some of the tools you need. I use a pipe cutter. This is a rigid one that I got at the Home Depot. It's very simple, pipe cutter. And we're going to cut the blade to length with that. I'm hopefully going to show you a trick here with cutting the blade to length. an X-Acto knife, and I use the X-Acto knife to cut the strip diffuser tube, and I'll show you how I do that and why I do it the way I do it. But in the end, it always works out really good. I've got this is a mechanical pencil that I'm going to use to mark my blade length with, and I have a tape measure to measure off the 34.5-inch length on the actual clear blade so we can cut it. So this is what you need for the project. Of course, you're going to need wires, a soldering iron, and a 330 ohm 0603 resistor when we get to that as well. But you can build a blade. The components to build this blade cost roughly, $110 or so, and you can build a top tier high quality blade at home if you follow these methods. Alright, so now what I'm going to do is I'm going to mark my tube at 34.5 inches. I order mine uncut. You can order them cut from the custom saber shop, but I'm going to go ahead and mark my 34.5 inches, and that pencil really doesn't want to mark my 34.5 inches, so I'm just going to throw in a scratch with my X-Acto knife. Either way it works. And I'll try and show you. My mark is right there, my fingertip. I know you're not going to be able to see it very well, but that's my mark. And let me go get my trick. I forgot to do that. I'll be right back. Okay, so what I'm going to do here, and you can use a piece of 7/8 inch blade scrap. This is a piece of 7/8 inch blade scrap. And if you'll notice, the 7/8 inch blade scrap actually fits into the hilt, but it's a little tight. So I think what I'm going to do is just my normal thing that I do, and I've got a 7/8 inch blade plug. This is an MPP blade plug, which is apropos since that's what we're building as a MPP, and this blade plug will actually slide down there into the blade to our mark, which you can see our mark right there. And I'm actually going to put the metal of the blade plug in under the mark. The metal of the blade plug is now in under the mark. So now what I'm going to do is I'm going to take our cutting wheel and I'm going to get it on our mark. And the reason I do this is it keeps that 7/8 inch plug, keeps this from, it looks like we're on the mark pretty good there. That 7/8 inch plug keeps this blade from compressing on the cutting tool. There we go. And now I'm going to cut our blade. And after 2 or so spins, I turn the handle a quarter turn. And I can already hear it cutting through. One more pass, maybe. Yep, we're through. So now I'm going to remove my cutting tool, and then I'm going to remove our piece of blade that we just cut off. And you can see our blade plug there, and you see I have a nice clean hole. Now typically what I do on these cuts is I'll use that for the blade butt end, and then the factory finish cut, I use that for the actual blade tip. So this is our rough blade with the blade tip in and the butt end on. So now what I'm going to do is I'm going to take the blade butt tip off. So now the blade butt tip is off, and I'm going to slide our strip diffuser tube into the hilt where it touches the tip. So you can see it going up to where it's going to touch the tip. That's how I want it to seat. So now our problem is this strip diffuser tube. Let me zoom back out here. this strip diffuser tube is now longer than our blade, which creates a slight problem for us. So I know that, you know, that's the very end, but you have to remember on our blade butt cap, on the butt end of the blade has to seat in there. So yeah, while that mark may work, that's still not going to allow this to seat. So we have to cut enough of that away for this blade butt cap to work in there like we want it to. So I have to take out, you know, another 1/4 of an inch. So basically what I do is I slide that out about another 1/4 of an inch, and you can do it by eye, and then I cut our strip diffuser tube with a knife, going around with a knife. And we're almost all the way through. And I can see that I strayed a little bit, which is fine because I'm going to get back down to our lower part, and now I can use the end of the tube as a cutting guide to trim this. Hang on a minute, because I need to get the bolt cap off so I can hold the tube where I need it. So now you can see that I'm cut to length. So now what we're going to do is we're going to put the blade cap back on the factory finished end on both the pixel diffuser as well as the tube. And then I'm going to install our butt cap, which now goes on all the way. So we're solid there. So our blade is built. It's ready to receive the foam and the Neopixels. So that's what we're going to go to next, are the Neopixels. And we'll see you back up at the soldering bench, where what we're going to do at the soldering bench is we're going to, we don't have to cut these. All we need to do is tin these pads, solder our wires to it, and then we have to add the resistor onto our blade target. And then we're going to solder our wires from the pixel stick onto our blade target, and we're going to be ready to do the final assembly on this blade. It's just that easy. I do also cut the foam, and we'll do that right now so you guys can see it, because the foam is also 40 inches long. And what I do to cut the foam is I'll put the foam down in the tube all the way, and this is going in the butt end, and there you can see it stops there. So I'll take a pair of scissors, and again, this is, I want my factory edge of the foam on the blade tip. So I got my factory edge of the Neopixel diffusion tube against the factory edge of the blade piece, and all that's on the blade tip. So all my cuts I want down here on this end, because this end is in the lightsaber. And I'm going to go ahead and cut my tube the same length of the blade, and that's okay, because when you put in your blade target, you can see it compresses that foam there a little bit, and that's fine. That's exactly how you want it. It's okay to compress that foam a little bit. You're not going to hurt anything. So now our foam tube is cut to length, our blade tube is cut to length, our inner diffusion tube is cut to length, and we have our blade tip as well as our butt end ready to go. So this is the rough build of the blade. It's ready to receive the strips. So all that's left is to wire the strips. You can see this process is much simpler and quicker than my last video when we're building a Neopixel blade from scratch. Now, my scratch built Neopixel blades are still very awesome, but they're a lot more work than these KR blades are, and they're a lot more durable than the KR blades are. These PCBs are solid. They're not as flexible as the strips. So they're going to be prone to more breakage, you know, if you're dueling with them. So these aren't really suggested for dueling. If you want a dueling blade, I can build you a dueling blade. Number one, it needs to be thick-walled. Number two, it needs to use, you know, it needs to use 35-35s versus these KR pixel strips. But you need a Neopixel blade for cosplay or just to show off your lightsaber. These KR pixel sticks are the way to go. This is the best solution out there to get the best and brightest looking blade you can possibly get without going quads or triple strips. I mean, the KR strips really look fantastic in a blade. Let's go wire this thing up. All right, so here we are up at the bench, and we've got everything we need to build our blade, including our KR pixel strip. This is the strip I showed you downstairs when we were doing the blade assembly. And I'm going to bring in an optional piece that I do, which is one of these positive male plugs. Now, I built a test rig, and I'll put the link to the test rig, to the video that we built this test rig on Megtooth Monday Live. And I'll put the link in the description down there in the doobly-doo. But on my test rig, I have a female plug, and that allows me to test Neopixel strips. Now, of course, what I think I'm going to do here when we build these strips is I'm going to go ahead and test them to make sure they light up. Now, you're going to have to take my word for it, because you're only going to see the first few pixels light up, because, you know, I want y'all to be able to see the little things, not necessarily the big things. We'll do an overall video downstairs once the blade gets built, but this is a simple test rig I built out of an MHS V6 chassis and a Prism 5.5 with this negative Neopixel plug. This rig allows me to test Neopixel strips and blades and so forth. And so I am going to include this extra step that I do to test the actual strips before I install them in the blade. But certainly, you know, it's an optional test that you don't necessarily have to do. It's something that I do to, you know, add to the surety that things are going to work as I expect them to work once we get up and running. So let's get off to building the actual wiring on the blade. Now, you can buy, you know, I buy huge kits of these 0603 resistors. Like, here's a huge kit of them. It's got all kinds of packs in it. Made in China. It's Chinesium. But these 0603 resistors, which I'm going to show you, they're really small. And there's, you know, 1, 2, 3, 4, 5, 6 left in this pack. These are actually 330 ohm, which I'll try to show you. You can see right there, it's 330 ohm resistors. And this blade is designed for a Proffie, which already has the data resist installed on it. But I'm going to go ahead and add the resistor onto the blade, because that way the blade can be used in any saber, even not a Proffie saber. And if any of you are wondering, Frederick's tested the impedance here, and he's run double, triple resistors, you know, I think up to 1500 ohms, and the data signal still gets through just fine to the Neopixels. So don't be afraid if you have a Neopixel on the Proffie and a Neopixel on your blade, or a resistor on your Neopixel blade, because the data is still going to get through. Remember, on a Neopixel saber, these resistors aren't limiting the voltage or the amperage to your blade. They're actually just stabilizing the data signal. They're a purifier, if you will. But at any rate, let's go ahead and get one of these 0603 resistors out. And I'm going to zoom in on it so you guys can see it, because it's tiny. It's very, very tiny. And I'm going to try and push it to you where you can see it. I'm going to have to get those wires out of the way. I'm going to push it over there. there it is. Now I'm going to try and turn it upside down so you guys can see it better. There it is. That's our 330 ohm resistor, and I'm going to put my finger next to it for size. You can see they're very tiny. I know a lot of people are intimidated by these. You can see my dirty fingernails. But don't be intimidated by the 0603 resistors. I'm going to show you, I think, a fairly simple method to solder them. Stand by. Okay, so now we have our blade target end here, and I'm going to go ahead and pre-tin our blade target end. Number one, to receive all of our power and Neopixel wires. And let me clean off my soldering iron tip here. Let's apply some fresh solder to my tip. And let's go ahead and tin these pads. So I'm applying the iron to the pad and then adding solder to the pad. Now right now I'm tinning the data, positive and negative pads on our target. And after I tin those pads, and you can see my little resistor right there, I'm only going to tin one of these resistor pads. Now, if you're not using a resistor here, you need to bridge those two pads or your connector won't work. But I am using a resistor here. So what I do is I heat up I tin one of the pads, and then I come in with tweezers. And I don't know if these are my favorite tweezers or not. And I'm going to grab that resistor. And then, let me see if I'm zoomed into the maximum here where you guys can see this. And I'm going to bring in my soldering iron. Normally it's easier if you tape this down. But I'm going to heat up that solder that we laid. And there are the 0603 resistors in place. Now I'm going to use my fingernail to push it down to make sure it seats in that solder, like it did right there. And then once I get that side soldered, then I'm going to come to the other side of the 0603 resistor, and that's when I'm going to go ahead and solder the other side in, like that. And then I'll make sure that the initial side we soldered is good as well. So there we go. There's the 0603 resistor soldered in. It's relatively easy if you have tweezers, and you know, my hands are really shaky, but I can still pull this off. It's not as hard as you think. But that's our blade target end. We'll get back to that in a minute. So I'm going to set our blade target aside, and now I'm going to bring in our KR Pixel Sticks. And we're going to pre-tin all these pads to receive our wires. So I'm going to clean my soldering iron here. I'm going to put some fresh solder on my iron. Now these pads are a little bit bigger, so you're going to have some time on contact here. And I'm putting my tip on the pad, and then I'm adding solder. And there's one tab pinned. Pinned. That's crazy. Now I'm going to tin our data pad. Trying to get it in frame here where y'all can see it. So I'm holding my iron onto the pad so the pad heats up, because it won't take solder unless it's heated up. And there you can see our center data pad is now tinned. And now I'm going to tin our negative pad. And there our negative pad is tinned. So mondo success. Now, on these VDD, let me get something to point. Well, I guess I'll point with a positive wire. This VDD here that you see here, this is your positive line. So your positive wire needs to go here. The center one is DIN, data in. That's your data pad. And then the negative is marked, I can't read that because the writing's so small, but it's negative. So this is negative, data, positive. So now we're going to add our wires to the KR Pixel Stick. So these are, I'm going to zoom out here so you guys can see. Let's zoom out. So these wires that I'm using, this is a 22 gauge wire, and I'm only going to strip enough wire to, and also I'm twisting the wire before I tin it. I'm going to dip it in a little bit of flux. I'm going to bring in my solder here and put some solder on the iron. I'm not using helping hand, so I'm using the sloppy tin method, which is just putting solder in my iron and then adding it. The appropriate way is to put the wire in a holder and then tin it with the solder, not the pad like you just saw me do. And what I'm going to do is, now I'm going to zoom y'all in a little bit more so you guys can see what I'm going to do. I'm going to bring in the wire, and I can see it looks like I need to trim some off of that wire. So I'm indeed going to trim a little bit off of that wire so it's just long enough to cover the pad. That's actually going to be a little bit shorter than the pad, but that's fine. Now, I'm going to put the wire in my hemostats because they get heated up here. And sometimes it's easier to do the data wire first because the data wire is in the middle, but I've done enough of these that I think it'll be okay. But I'm going to put our positive wire, y'all can't see that because my hands are in the way. I'm putting the positive wire on the pad. Let me grip that a little bit differently because you guys aren't going to be able to see that. I'm trying to do this in a way that y'all can see, and of course the tripod is in the way that the camera's sitting on, as usual when I'm filming. Come on now. Help me out here. So here I have my wire, we're ready to roll. I'm going to add some solder to my tip. I'm going to heat the pad that we've pre-tinned. And the solder is flowing really good. Ooh, I got a bridge there. That ain't good. Might have had a little bit too much solder on the tin. That's all right. We'll clean that up. We'll make sure there's no bridge there. We definitely don't want that bridge there. Really too much solder there. There, I've cleaned up the bridge. I don't know if y'all can see that. There's no longer a solder bridge. We'll check it with a multimeter because I'm kind of anal about the multimeter. And let's make sure we're good here. So I don't know if y'all are going to be able to see it or not, but basically I'm going to reflow this joint. I'm going to re-liquefy it. And there, I'm happy with that. So I re-liquefied the joint, and it looks like we've erased the bridge from there. So we're solid there. Now I'm going to bring in my data wire. The data wire I'm using today is 26 gauge, and it's already pre-tinned. So I'm going to go ahead and put the data wire in my forceps so I can bring it in here and try and get it where you all can hopefully see it and see my solder there too. I try to keep my solder here handy. And let's put some solder on the tip and let's get our data wire down. Bada bing. Our data wire is in. I'm going to release that. Next is our negative wire, which is already cut, twisted, and pre-tinned. And I'm going to go ahead, at least on the end that's going on the blade. Now I'm going to have to do the other end so that we can attach that male plug to put it on my tester. So there is our negative wire getting ready to go on. You can see just enough wire stripped to go on the pad. I'm going to add some solder to my iron. So we're getting good heat conduction there. And we've got a good joint there. So these are big gloppy solders. I put way too much solder on there. It's not my best soldering job here, and it's probably because I'm tired because I've worked all day. Stand by, I'm going to get the multimeter. Alright, battery on my camera was low, sorry about that. So I'm going to bring in some helping hands here to kind of hold that while I tack it. And when I say helping hands, I mean my hemostats. My hemostats are going to be quasi helping hands. There, we got a quick tap, quick attachment on that one. Now I'm going to tack our negative line really quick and dirty. There we go. Now, what I do to hold these wires apart to make sure that they don't touch each other is I'll put them in my hemostats with some separation on them. And I have a wider pair of hemostats that can hold that better. But we're just doing this to test the pixel strip. And I'm going to use my test rig here that has the female plug on it. So it's going to be out of the screenshot. But what I'm going to do is I'm going to plug in our test rig into our pixel strip, and then I want to make sure I get the solder and anything conductive away from the strip here and bring the strip into the frame. And I'm going to go ahead and take my test rig out of deep sleep, and here it's boot. Now let's try ignition. Oh yeah, lock up, flashers. I'm getting what I expect. Let's try a different color. There's red, and it's lit all the way to the end, so I know that this pixel strip is good. I would have expected nothing less from Cal Strip. So that's a successful test of the strips. So we're now done with this plug. So I'm going to quickly desolder all these tacks. We know the strip is good. We know that everything else is good. And I'm going to unplug that plug. And we'll set it aside for later because I'm always using these things. Now, we get back to the beginning. I'm going to bring in our blade end. Now, on this blade end, I'm not going to have really long wires here. So what I'm going to do here is I'm going to cut, we'll say they're going to be about yay long. So I'm using here on positive and negative, I'm using 22 gauge PTFE wire, and on data I'm using 26. So now I'm going to strip just enough to cover the pad, which isn't a whole lot, y'all. You can see those pads on that blade target end are kind of small. So my stripped wire will likewise be small. Jeff Birch did a video about this today. So I'm going to strip just a little bit of that wire. And I'm going to likewise strip a little bit of this wire. And this data wire is 26 gauge. And then a little bit of my positive wire, which this is 22 gauge. And when you're this short, you want to be careful you're not pulling the insulation away from the end. Alright, so they're all twisted. I'm going to add some flux to all three, just a little bit. And I'm going to bring in our solder. We're going to pre-tin these wires to go to the pads on our connector. Now this is how you should be tinning wires. Heat up the wire with your iron and then add the solder to the wire, just like that. Now comes the kind of hard part. I'm going to solder our Neopixel data in. Bam. Then our negative to the negative. I'm going to add a little bit more solder to that. That's a good joint. And our positive to our positive. And we're looking good. Now, I'm going to bring our multimeter back in. Make sure I don't have any bridges there we don't want. And we're almost done. So let's check between, number one, we know we're in continuity mode. Negative in data, no continuity. Negative and positive, no continuity. Negative and positive, no continuity. Negative and data, no continuity. Data and positive, no continuity. So, and I'm going to check between negative and positive. No continuity. So we're solid. We're definitely solid there. So that's basically wiring up the blade. It can be that easy. You can run 2 power wires. There are pads on the back side. And, you know, you can run the additional data wires here on the back. So if you've got smaller gauge wire like 24 or so, you know, you can certainly run that. But you can see what I do is I get the wires bent to about where I want them so that the blade's centered on the pad. And this is our target end that's going into the blade. And now we're going backstairs to do the final blade assembly, and we'll test this puppy. Alright, so now hopefully for the conclusion of our video, we have our blade that we have put together with the foam and the strip diffuser in here. And I'm going to go ahead and take the foam out of there because we're going to need that. I'm going to take the foam out of the blade. Now what I'm going to do is I'm going to take our blade end cap and I'm going to slide our blade end cap over the KR strips just like that. And it can temporarily snap into the butt cap, and then I'm going to slide our Neopixel strips into the foam that we have cut, and finally I'm going to slide all of this home into the Saber, and you can see the butt cap coming home there. So there we have our completed blade. Now the only thing that I'm not going to show is I do use E6000 to secure the blade tip on. And it looks like, hang on a minute, it does look like the diffusion tube slipped on me there somewhat, so I'm going to force it home. But I do use E6000 to secure this, but this is the completed blade. It's ready to roll. So this blade was built for this Saber. So I'm now going to put our completed blade into this hilt, and here we go. This is the first time this Saber's ever had a full blade fired in it. Let's go back one font. Little spark tip ignition going on. Nice even blade illumination. Minimal shadows because those KR strips are awesome. And let's go to... This is a specialty blade, so let's see if effects work. I need to adjust the clash sensitivity on this Saber. It's a new install. Let's check something else here. It works. So thank y'all for coming along for the ride on this blade build for this MPP for Curtis Smith. And now this is in posterity. So you've seen me do Neopixel strip blades. Now you've seen me do the KR Pixel Stick blades. These KR Pixel sticks that I used in this build are available at www.thecustomsabershop.com in the USA. If you're in the UK or Europe, you can get them from www.thesaberarmory.com, which is KR Sabers website. And the blade materials I used are available at both locations as well. This was a successful blade build. Happy with the results. Hopefully Curtis is happy with the results as well. And now off to fine-tune the finishing touches on the Saber, like getting the wires installed and everything. But thank you everybody for watching as usual. I really appreciate y'all tuning in on my channel. And as always,